Okay, this is the situation for question 8. A is here, it's on a smooth table, so we can assume that there's no friction. That's a question later, we can assume no friction. We're going to use Newton's second law, first of all, for particle A. We can see the only force acting in a horizontal direction. We're assuming here, it's fairly obvious, that that one's going to accelerate in that direction. B is going to accelerate downwards. So for A, we can say Newton's second law says that T in that direction, because we're using Newton's second law in that direction, T is just going to be the mass, which is 0.5 times A. Now, if we do the same thing for B, Newton's second law, and we're going to use it in a downwards direction, acting down, we've got 0.8 g. Acting upwards, we've got the tension, so that's 0.8 g minus t is the resultant force downwards, and that's going to equal the mass 0.8 times the acceleration. Now, if we call that one equation 1, that one equation 2, as usual, I'm going to do 1 plus 2, so I'm going to do t minus t disappears. All I'm left with on the left-hand side is 0.8 g, and if I add the right-hand sides together, I've got 1.3 a. So dividing by 1.3 a is going to equal 0.8 g divided by 1.3. Now that comes out for a as 6.0307 blah blah blah. I'm going to save that in the memory on my calculator as a. I can now work out the tension. I'm just going to use that first equation, equation 1. T is just 0.5 a, so it's 0.5 times the 6.0307, and that comes out as 3.0153. In other words, 3.02 newtons to 3 significant. Now, we're asked to find the speed of A up here immediately before it reaches the pulley. So in other words, when it's travelled 1.3 metres. So I'm just going to use, because I know the acceleration now is this constant 6.0307, I can just use the Suvat equations. So basically for A, I know it's released from rest, so U is 0. V is what we're trying to find. The displacement is 1.3 metres, and the acceleration is that 6.03. So all I need to use now is v squared is equal to u squared plus 2as. So v squared is what I'm looking for. So u squared is 0, so it's literally just 2 times the 6.03 multiplied by the 1.3. That came out as 15.68, which means that v is then the square root of that. So that's 3.959 blah blah blah, which I can round to 3.96 meters per second. And remember, the assumption there, that part of the question, is that there is no friction. So that's the velocity, and it's the velocity at this point here where A reaches the pulley. I'm going to put that one in my memory. I'm going to call that one B because I'm going to use that later. Okay, we're now told that when A reaches the pulley, the string breaks. Now that's quite important because it means that when A has travelled 1.3 metres, B will also have travelled the same 1.3 metres vertically downwards. And at that point, when B is here, when it's 1.3 metres below the point where it started, the string breaks. So B is now effectively moving vertically downwards under the influence of only gravity. In other words, it's accelerating downwards at 9.8 metres per second. Okay, and we also know that at that point there where B is released, it's travelling at this speed, the 3.9539. So V there is travelling at B is travelling at 3.959 meters per second, and that's quite important. Now, if you read the question carefully, the question says, calculate, it says, B reaches the floor 1.2 seconds after the release of A. Now, if you read that carefully, that means 1.2 seconds after this point here, when A is released, not when the string breaks. So what we've got to do is work out how long it takes, first of all, for A to get from here to the pulley. In other words, we know its acceleration, so we need to just know the time taken for A to reach here. We already know the final velocity. I'm just going to go to here, and I'm just going to use these same, because we're talking about the same motion here, we're going to find t for this first bit of motion for A. And in fact, all I need to use there is v equals u plus at, which means that t is just going to be v minus u divided by A, which is that 3.95 3, the u was 0, a was the 6.03, just go down a bit, the 6.03, so in other words, and that comes out as 0.6565 seconds. Now that's the time it takes for A to go from here to here. In other words, it's also the time that it takes B to go from here to here. So this time here is 0.6565 seconds. Now that's quite important because it now says that it takes B 1.2 seconds to reach the floor from the time that A is released. So in other words, the time that it takes B to go from here, so after it's already dropped 1.3 seconds, must be the 1.21 seconds subtract this. So what we're now going to do is we're now going to look at B. So we're looking now at B after the string has broken. Now the speed at which B is traveling is that 3.959 meters per second. Final velocity, we don't know, don't care particularly. The displacement is what we're trying to find. The acceleration is going to be 9.8. Now that's in a downwards direction. The 9.8 is also in a downward direction. But the time, it's not 1.21, it's actually 1.21 minus the time taken for the earlier motion. In other words, the 0.6565. And that time comes out as 0.5534 seconds. So now I'm going to use this lot. S is what I'm trying to find, so I'm going to use S equals ut plus the half AT squared. So u, so in other words it's 3.95 blah 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 times the time taken. Well, that's 0.55. I've saved that in my memory as well, and I'm going to add half times the 9.8 because it's accelerating at acceleration due to gravity, and then multiplied by the 0.55 squared. And if I've saved all those numbers in my memory on my calculator, which I did, that comes out as 4.9919 blah blah blah. In other words, 4.99 meters.